So dear students, we'll continue with our last video. So we're doing the topic derivatives. Okay, it is yet to be explained yet. So under derivatives, we're doing slopes. And I've given a function for you, that is y is equals to x square, and I've asked you to tell something about the slope of this particular function. So today we are going to see how the slope of this function really looks like. So this is my x side, this is my y side. So for x0, y will be 0. For x1, y will be 1. For x2, y will be 4. For x3, y will be 9. For x4, y will be 16, and so on. So let's plot this graph. Okay, so this is my x side, this is my y side. X coordinate are 0, 0, 1, 2, 3, 4. Y side are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. So let's locate the coordinates. 0, 0 is this point, 1, 1 is this point, 2, 4. 2, 4 is this point, 3, 9. Roughly 3, 9. Okay, roughly 3, 9 will be this point, and so on. So when you join these points, so this function is not a linear function. It's not a linear function, not a linear function. Rather, it is a quadratic function. Quadratic function. Because y is dependent on the second power of x. So such function is known as quadratic function. And for this quadratic function, y is equals to x square, we're getting this kind of graph. And this graph is in the shape of a hyperbola. This graph is also known as hyperbola. So let's look how the slope of this particular function, that is y is equals to x square, that is hyperbola, looks like. So firstly we will calculate the average slope of this function of y is equals to x square. So first we see the average slope of this function. So average slope is basically calculated between 2 points. Okay, first see this 2 points between 2 and 3. Let's calculate the average slope between 2 and 3. So what we will do is we will make a straight line between these two particular points, 2 and 3. So make a straight line. Okay, make a straighter one. Just draw one line. So this is not a perfect curve for me here. So I'm drawing, like, I'm making a mess here. But you have to do this once only. So you have to draw one straight line from 2 to 3. So average slope between these 2 points. Average slope in this case from between points. Okay, between points, this point is my 2, 4, and this point is my 3, 9. So between points 2, 4 and 3, 9. So between these 2 points, my average slope will be change in y divided by change in x in the same manner. So from for this between 2 points, that is this and this, so we'll come from one point to another point without lifting my pen. You can go this way also. Let us go upward. So here to here, it is same. So when I go here to here, so I go this way, and when I go here to here, I go this way. That means change in y will be from here to here. It is going up. That means it is positive. And how much value did it travel? From 9 to 4. That means 5. Isn't it? Yeah, 5. Plus 5 divided by change in x is from here to here. Going this direction. So again positive. And it is traveling from 2 to 3. From point 2 to point 3. 2 to 3. 4 to 9. So coordinate of x is 2 to 3. Coordinate y is 4 to 9. So 2 to 3 is 1. So 1. That means the slope, average slope between these 2 points is plus 5. Similarly, let's calculate the average slope between these 2 points. These 2 points. Okay. That is, this point is my 1, 1, and this point is my 2, 4. So between points 1, 1 and 2, 4, my average slope will be change in y by change in x. So go from here to here, this point to this point, so this to this, so both are positive directions. So change in y is from 2 to 4. So you are going from 2 to 4. Sorry. You are going from 1 to 4. The value of y is 1 and the value of y, another y is 4. So 1 to 4. So plus 3. From x 1 to 2. X is going from 1 to 2. That is 1. So plus 3. So what we are finding here is, or what we got here is, the average slope between these 2 points is 5. But for the same function y is equals to x square, the average slope between these 2 points is plus 3. So average slope between this point is greater than this point. And it is true because this line is more steeper than this line. Isn't it? This line is more steeper than this line. That's why the slope of this line is more than the slope of this line. So it is from the fact of the definition of the slope itself. When you calculate the slope between these 2 points, the slope again decreases. So try it yourself. When you find the average slope between 0, 0 and this point is 1, 1. 1, 1. The average slope will be lesser than plus 3. The average slope decreases again. Why it decreases again? Because this is now less steeper than this line. So this is your homework. So one of the homework is find the average slope. Find the average slope between 0, 0 and 1, 1. So this is one of your homework. Okay, so actually what we were doing here is, we had a function that is y is equals to x square. Y is equals to x square, which looks like this. This is 0, 0. Some points 1, 1 point. Some points okay, let's do this here because like I cannot do it exactly. Okay, so I had a graph this way. Y is equals to x square. Okay, let's do it in proper way. So 0, 0. It's 1. Let us. This is 1, 2, 3, 4, 5, 6, 7, 8. Okay, do it up to 9. This is y direction. This is x direction. 1, 2, 3, 3 only. So 1, 1 is this point. 2, 4. 2, 4 is this point. and 3. 3, 9 is this point. So you have this kind of graph. So this is my hyperbola. So I have this graph. So for this graph I have calculated the average slope between this point and again average slope between this and this point. So you can take any 2 points, this point and you can calculate the average slope, and again you can take this point and you can calculate the average slope, and the average slope of this and this changes. So for each 2 points on this particular graph, the average slope will be different because it is not a straight line, because it has a different average slopes because it is a curve. For a straight line, between any 2 points the average slope will remains the same for every 2 points. You can check that also. So now we had an idea about calculating the average slope between any 2 points, but we still don't have an idea. If somebody asks you what is the slope, average slope at a particular point 2, what is the slope of this curve at this point 2, or what is the slope of this curve at 2,4 only, 0.24 only, what is the average slope of this particular graph at 0.11, what is the average slope of this graph at the 0.39. So this we don't have an idea, because at 0.39 like we don't have any change in y or change in x, because the point is 39 itself. What is the average slope at 0.24 only? So we cannot calculate, because at this very particular point we don't have change in y or change in x. The change in y and change in x occurs when you are going from one point to the another. But if somebody asks you to calculate the slope at the very particular point, one point, then now it is difficult for us to calculate the average slope, because we don't have an idea about change in y and change in x. So how we calculate the slope at a particular point on the curve? So in that case we will not calculate average slope, but rather we will calculate at that case we will calculate instantaneous slope. So for such cases we will calculate the instantaneous slope. Instantaneous slope means slope at that instant or point. Slope at that particular point is known as instantaneous slope. So if somebody asks you to calculate the slope at 2,4 or average slope at 2,4, so you will calculate the instantaneous slope at that particular point. So how we calculate instantaneous slope? That is given by our derivative. So now from this particular concept onwards, now we need derivatives. So when the derivative is needed when somebody asks you to calculate the instantaneous slope for a quadratic equation, or somebody asks you to calculate the instantaneous slope for non-linear function. So derivatives is required to calculate the instantaneous slope derivatives is required to calculate the instantaneous slope for non-linear functions. So this is it for today. So hope you will do your homework of today. So from tomorrow onwards we are going to study derivatives. Thank you.